Welcome guys, this is 1.5 measuring angles. So today we're going to learn about angles, which is my favorite, and I just want to start off by saying that angles are measured in degrees. So let's go ahead and write that down. The other thing we want to know is that for angles the symbol looks like this, or the one that I will always use looks like that. Alright, so let's go ahead and talk about what an angle is. An angle is formed by two rays with the same endpoint. So basically they connect at that same endpoint. Now you'll see that the rays are the sides of the angle and the endpoint is the vertex of the angle. This one right here is an important word, so I'm going to go ahead and underline it. Vertex. That's going to come up and we're going to learn what that is in a second. Alright, so let's go ahead and talk about the first type of classifying of an angle, which we have a total of 4. So the first one here is an acute angle and the next one is a right angle. Alright, so let's go ahead and talk about an acute angle. It is less than 90 degrees, but this won't even make sense if you don't know what 90 degrees is. So a right angle is equal to 90 degrees. You'll notice that this here is a right angle, so that's why you should definitely draw that diagram. And the way we know that it's also a 90-degree angle, a right angle, is because it has this little box indicating it. It won't normally say 90 degrees. This box will be present though. And that's what makes it 90 degrees. So notice that an acute is less than 90 degrees. And if I take this little stencil that I had ready to go and I put it on top of my acute angle, you can see that this acute angle is less than 90 degrees because this one is 90, so therefore it's less than. Another way that I like to think of it is that if we have an acute angle is cute, right? It's small, less than 90 degrees. It's smaller than the 90 degrees, right? So acute, cute, think of it that way. All right, I'm going to use this acute angle to go ahead and help us write the 3 types of ways to name an angle. So let's go ahead and begin there. All right, the first way you're going to want to name all the time, and I'm going to go ahead and take this time to talk about the angle that I haven't talked about yet, and that's using just one letter with its vertex. That guy right there. The corner is the vertex where the 2 rays meet at the same endpoint. This is our vertex. And so, like I said, it's the way you're going to want to name it all the time because it's easy. Angle E is the acceptable way. But again, you want to stay away from it because this second method, which right here, this is the one you want to use all the time. You want to go ahead and use 3 letters. The 3 letters that you're going to use are the ones that help form the angle. Which ones am I referring to? I'm referring to the 3 points on your angles. So we're talking about angle F, E, D. Now, yes, it has to be in this order because the vertex has to be in the middle. So it has to be in the middle, this vertex. Or you could also name it angle D, E, F. Once again, you'll notice the vertex is in the middle. This is important. It has to be. If not, you're not saying the right angle. Okay, so make sure that the vertex is always in the middle. And the last way to name your angle, which isn't always going to be given, is angle 2 with using a number that's in between the 2 rays. Angle 2. So these are your 3 ways of naming your angle. All right, let's keep moving. So we got an acute angle and a right angle. Those are the 2 ways, and we got 2 more ways. So let's go ahead and go to the next one. The next one is an obtuse angle. An obtuse angle is more than 90 degrees, but less than 180 degrees. So you'll notice again, if we were talking about 90 degrees would be right there, but it's more than 90, so that's why it keeps going, but it's less than 180. Now the next one is a straight angle, and a straight angle is equal to 180. You'll notice that a straight angle also kind of looks like a line, but we're talking about the angle, and that's why we refer to it as a straight angle, because it's equal to 180 degrees, just like it says there. So that's why if we refer back to the obtuse is less than 180 but more than 90. And these are the 4 ways to classify your angle. Basically just by their measures, and that's it. All right, the next term that we want to talk about is congruent angles. Now, we already know what congruent means. You should at least. It's that symbol that we talked about in the past, congruent. This one right here, congruent. You'll notice for congruent angles, they have the same measure and they will have the same amount of tick marks. So just like this one here has 2 and this one here has 2, they have to have the same number of tick marks in order for them to be congruent. Just like this one has 1 and that one also has 1, right? When we see our congruent angles, we always want to write a congruent statement. This is something you should be familiar with already. Anytime you see congruent objects, you state them. So for instance, we say angle A is congruent to angle B. And the second pair there is that angle C is congruent to angle D. So these are your congruent statements, saying that they are congruent to each other, the objects are. All right, let's go ahead and talk about the last concept. Now, the last concept is your angle addition postulate. And your angle addition postulate is very similar to your segment addition postulate. So, what we want to know is that basically all we're saying is we're going to add 2 pieces of our smaller angle and make it equal to the larger one. So, what am I talking about? I'm referring to angle AOB plus angle BOC is equal to angle AOC. So once again, I'll say angle AOB plus the other small angle, which is angle BOC, is equal to the large angle, which is angle AOC. Now, you'll also notice that here, there's an M in front of all of these, and I don't actually ever use it, but the book does, and you should know what it means. This simply means measure. Well, that makes sense why they would use it, because they're basically saying the measure of angle AOB plus the measure of angle BOC is equal to the measure of angle AOC. So, small plus small equals large, or red plus purple equals blue, however you want to see it. All right, the next part of our statement is talking about angle AOB, same concept, angle AOB plus angle BOC. Let me go ahead and fix that up a little bit. Angle BOC is equal to angle AOC. If you look back to our terms, you can notice that angle AOC looks very familiar and it looks like the straight angle that we have here, right? So that's exactly what it is that the angle AOC is equal to 180 degrees because it is a straight angle. So going back to our information, angle AOB plus the other small angle, which is angle BOC, is equal to 180 degrees, our straight angle. All right, let's go ahead and jump into examples. So let's go ahead and do the first one. It says write 3 names for the angle. So that's what you're going to do. At this point, write 3 names for the angle, press pause, and give it a shot, please. All right, so the first angle that I'm going to go ahead and say, which I hope you press pause, the first angle is the easiest one, which is angle U. Right? The one that you always want to use, but you shouldn't. The second one is the one that you should always use, which is angle VUT. Or you can also call it angle TUV. You don't have to name it both. Angle 3 is the third way of naming your angle. All right. Remember, we do have to practice that because you need to know how to name an angle, and if you're stating the wrong letters, then you're not going to correctly state the correct angle. All right, let's go ahead and jump into the next one. Now, this one I'll help you out with the first one, and then after that, I'm going to let you do the rest. So, it says, find the measure of each angle, then classify the angle. So, they want you to find the measure, which means give me a number, and classify the angle. So, classify it. So, basically, we're talking about acute, obtuse, right, straight. That's classify. And measure, they want an actual number. So I'm going to go ahead and start with the first one. The first one is angle GHK. GHK, I'm going to highlight it just so we can see it where it's at. GHK is referring to that angle there. So I'm going to start where it starts here at the very bottom, right here, where it starts at 0. And I'm going to work my way around over here. So if I start down here and I say, okay, this is 0, 10, 20, 30, and then I'm going to keep going, 40, 80, 90, then it gets to 120, and it stops. Now, I can notice if I zoom in a little more, it's not at 120, right? It's technically at, let's see, it's in between 120 and 130, so maybe it's 125, but just to make sure, I'm going to count how many little tick marks are in between. So we're talking about 1, 2, 3, 4, and 5. Yes, so that is 125. So the measure of angle GHK is 125 degrees. And based on my definitions, it has to be more than 90 and less than 180, which is going to be our obtuse angle, right? Obtuse angle. Press pause and go ahead and do the last two, B and C. All right, I hope you press pause. Let's go ahead and jump into the problems. Angle JHL, let me go ahead and highlight that for us. JHL is referring to this angle here. Oh, that's an easy one. Hopefully you got it immediately. It's referring to 90 degrees, that one right there. So this one is 90 degrees, which means it's a right angle. The last one, let's go ahead and write that one out. The last angle is angle LHK. So that angle. And that one's a little tougher because these don't start at 0. So what I'm going to do is I'm going to go ahead and use the information that I know for this guy here. I know that's 125. And I'm going to subtract it from this guy. And I know that's 90. So if I subtract that, I believe that's going to be 35 degrees. And that's what my angle is. My angle is going to be 35 degrees. And since by definition, it has to fall under acute angle. All right, that's it. Let's go ahead and jump into the next example. So this next example, I'm going to go ahead and read it and see what we're going to do first. So it says, suppose that the measure of angle 1, it said it's 42 degrees. And then suppose that the measure of angle ABC is 88 degrees. Okay, and they want me to find the measure of angle 2. So I think if I go back to my notes, I'm going to be using angle addition postulate. I think that's what's going to be happening. So let's jump into it. Notice I already started color coordinating, and that's why using highlighters is so important. I'm going to go ahead and just highlight this guy, 1 red. And angle ABC, measure of angle ABC, green, since I've already hit it up with that. And the measure of angle 2, I'm going to hit it up with the blue. Now, remember, we always want to start with the geometry part, and I'm going to help you with that, and then I'm going to ask you to press pause so you can solve the rest of it. So, again, the geometry part is saying that this angle plus this angle is equal to that one, not numbers, plugging in that statement, right? So let's go ahead and write that statement out first. So we're referring to angle, in this case, we have to use angle 1 plus angle 2 is equal to angle, and then we have to use 3 letters here, so we're going to say angle ABC. Now, I know what they gave me for angle 1. They gave me 42 degrees, but they want me to find angle 2, so I'm just going to leave it that way, or I can put that measure just so you know that it's not a number, is equal to angle ABC, which is 88, right? They gave us that information, so 88. And there we have it. All we got to do is subtract the 42 from both sides of the equation, And we're left with the measure of angle 2 is equal to, well, if I subtract that, that's going to be 6 and 4. So the measure of angle 2 is going to equal to 46 degrees. All right, let's go ahead and finish up with our last example. Okay, so it says, ray AC bisects angle DAB. Okay, I hope you remember what bisects mean. That's an important word. We'll come back to it in a second. Let me finish up the statement. It says, if the measure of angle DAC is 58, what is the measure of angle DAB? So this is what they need us to find. They want us to find this information, right? Okay, so bisects. We are familiar with that word because back, I don't even know when, we talked about segment bisector and what bisect means. It means to cut in half. So that's what it's saying, that the ray, which ray? This ray, is bisecting our angle DAB, which is this angle here. It's cutting it in half. And so it's referring to these angles here, those angles there, they're congruent. You'll notice if I take all of this away, well, yeah, they have congruent markings. Those are there for a reason. So let's go ahead and talk about that. All right. Remember, if we have congruent markings, we always want to state the things that are congruent to each other. So we're going to say that angle DAC, which is this angle here. I'm going to take this away for a minute. This angle here is congruent to angle CAB. Angle CAB. And if I know what angle DAC is, which is 58, then I know that angle CAB is also the same. Now at this point, I'm going to let you go ahead and press pause so that you can go ahead and try to figure the last part out. I'm not going to help you with that just because it's kind of similar to the previous problem, which is using the the angle addition postulate. All right, so I hope you went ahead and used the angle addition postulate, which is saying angle DAC plus angle CAB is equal to angle DAB. I know what these are. This is 58, and this is also 58, and this all is going to equal to my angle, which is angle DAB, and so that's going to be 116. And remember, it is an angle, so we're going to say 116 degrees. And that's it, guys. Thank you for